Today we're talking about the material for section 1.2 of the course. This is the Math 24 section in order to get us ready for the 124 section. So to start, we're going to talk about interval notation. Now, interval notation is basically a subset of the number line. So if I have a number line looking like this, and I take some portion of it, let's say from 1 to 3, we have different ways of representing all numbers between 1 and 3. So all intervals are actually just subsets of this number line. And we represent it two different ways. We either write it down with an inequality like this, or with an interval notation like this. Inequalities like x greater than or equal to -3 means all x values greater than -3. So if I want to write it down as an interval, we either use brackets, which means we include the last number, or we use parentheses, which means we exclude the last number. So for x greater than or equal to -3, this is or equal to, which means I use brackets, -3, comma, infinity. So meaning I go up and on and on and on. And we always use parentheses with infinity. For something like b with, so this is our answer to A, for something like b with x not equal to -5, we want to use something called the union. So we want to go from all negative numbers up to 5. Then I'll use a parenthesis to say I'm not including 5. Then I see a union to stick these two sets together. And I'm going to pick this back up at 5, but not including 5, and go on to positive infinity. So this essentially includes all numbers from 5.000001 all the way up to positive infinity. And from here, we go from negative infinity up to 4.99999. It's kind of the idea. But we're skipping over 5, which is exactly what B asks us to do. Now we can go the other direction, right? So if we have C, something like negative infinity to 4, we'll say, well, that's x greater than 4. Now I'm not going to say or equal to. Oops. You know what, guys? Let me mix that up a little bit. X less than 4. We're going from negative infinity to 4, not all the way up to positive infinity. So that's x less than 4 to give us all values less than 4. For D, then, we have from -2 to 7. So that means we write down 2 is less than or equal to, since we have brackets, x, which is less than 7. I totally left off my negative. -2 less than or equal to x less than 7. And that's how we translate something like D into interval notation, inequality notation. All right, moving on to the next one, factoring trinomials. To factor a trinomial, we want to think about things that multiply to 15, but add to this middle number. And we want to be able to write them down in these parentheses like this. And we'll have x's here, and we need to figure out a plus minus for this value and a plus minus for this value. Whatever number we fill in on these right-hand sides needs to, again, multiply to 15 and add to -2. So we have to think about things that actually multiply to 15. Well, 3 and 5 multiply to 15. So 3 and 5 are great options. Now, we also see that this is a minus in front of the 15. So we know that the two things that multiply must be a plus and then a minus. So that way they multiply to a minus. So when we think about, well, where do we put the 3 and where do we put the 5? Because we know they have a difference of 2. Well, the 5 is the bigger number, and this value in the middle is negative. So we put the bigger number with the negative and the smaller number with the positive. Those two then overall bring us to a -2 when you add them together. We'll do the same thing for the other one. And again, we'll just start with our parentheses and our x's for our placeholders. Now we look at the signs, right? We have a positive here and a negative here, which means we must have the same signs, since either a positive and a positive multiplied to a positive, or a negative and a negative multiplied to a negative. Well, we must have a negative because they also add to a negative number. So they're both negatives. Okay. Now, what two things multiply to 16? Well, 4 and 4 multiply to 16, and they add to 8. So if I put those in, I'm going to have a minus 8x when we add them, and a plus 16 when we subtract them. We can always check our work by refoiling it back out like this. And we see when I do all of these different terms, we end up with a minus 8x in the middle. So we were definitely correct on that last one. That was just our check. You don't have to do that step, but it's helpful. All right, so now for the last one, solving when an expression equals 0. Here, if we have 3x minus 12 equals 0, I want to solve for x. So what I can do is I can add 12 to both sides, and I get 3x equals 12. Now I can divide by 3 on both sides, and I get x equals 4. And that's our answer. Now the right-hand side one is the more interesting one, part B. When we have x squared minus 4x equals 0, we don't have a third term in order to work with this like we do in the above, but we do have a common term, right? Each of these have an x in it. Here we have 2 x's, here we have 1 x. So I can actually factor out an x and write it like this. Now, any time that you have two things that are multiplying to 0, right here I have an x times x minus 4 equals 0. I'm going to set both things equal to 0. All right, and this one immediately gives us an answer, x equals 0. But on this side, we have x equals 4. So those are the two x values where where this expression equals 0. Now go ahead and give the rest of the worksheet some practice and reach out if you have any questions.